Good afternoon, everyone. We're going to start off the way we normally do, with a little checkpoint, homework quiz. So I think I returned those to you on Friday, so you should be all ready to go here. So here's your question. Okay, 7 women and 5 men try out for a mixed curling team, 2 men, 2 women. How many different teams can be made? Okay, so we're going to get out your piece of paper, give us a try, and in about 2-3 minutes, we'll pass them all in, and we'll go forward to the note. Okay, so this would be a good time to pause the video and wait for that to be done for 2 or 3 minutes. All right, so for what we're doing this afternoon, it's problem-solving combinations, and I'm going to show you a couple extra things. Kind of like how with permutations, we had to do some extra things with, well, what if some of them are the same? Okay, for this, we're going to go back to the Harvey's problem that we did way at the beginning. Okay, so you might recall we developed this pattern, right? If you have one topping that leads to only 2 possible burgers, right? It's like, lettuce, a burger that has nothing, or a burger that has lettuce. And the next one was like lettuce, tomato, and we went through. Okay. And we noticed that pattern, right? And it ended up just being powers of 2. This is 2 to the 1, 2 squared, 2 cubed, 2 to the 4, and so on. Okay. So now that we've talked about combinations, we can look at this a slightly different way. Okay, but it's going to lead to the same answer. So let's say I was in a situation where I had 2 toppings. Okay, and I don't remember the particular order, but let's say it was lettuce and tomato the first time we did it. Okay, so when I'm putting together a burger, okay, what are the different things that can happen? Well, I could take none of the toppings. So there's 2 available, and I choose 0. Okay, and that is equal to 1. Okay, I could just have a single topping. So that is 2 choose 1. Excuse me, which ends up being 2. Okay, and finally I could take them both. Okay, 2 choose 2, okay, which is also 1. Okay, and again, this one is important because in terms of topping the burger, I don't care what order they go on the burger, right? I would not call a burger with lettuce first and then tomato different than a burger with tomato first and then lettuce. Okay, I'm personally not that picky. So if I look at these numbers though, right, I've got 1, 2, and 1. So if I total those up, right, I end up with 4, okay, which is what I have here. So I took all the different options, right? There are 2 things, and I could have picked none of them. I could have picked exactly 1, and I could have picked exactly 2, and that totals up to 4. Okay, and similarly, if I went through this whole process for 3, right, if I started with, 3 choose 0, okay, that's equal to 1. Okay, 3 choose 1 is equal to 3. Okay, 3 choose 2 is equal to 3. And 3 choose 3 is equal to 1. Okay, and add those all up, and surprise, surprise, we get 8. Okay, so if I do every single choose term, okay, from a certain number, 0, 1, right, for 3, I did all the possibilities, I get 8. Okay. So if you're adding all those up, one other way of saying that would be, what's all the possible subsets? How many subsets of size 0? There's 1. How many subsets of size 1? There's 3. How many subsets of size 2? There's 3. Okay, when I add up all my possible subsets, I get to the power of 3 there. And we're going to summarize that in a moment. Okay. Now, one thing that didn't come up, and when we were there, okay, what if you can ask for extra toppings? Okay, what if I can get 2 tomatoes or 2 leaves of lettuce or 2 pickles instead of just 1? Okay, how would that make this situation different? Right? What could I do with it? Well, let's say there's a limit, right? You can have, I don't know, up to double, right? Just double, okay? Well, then instead of, when I'm thinking of my different toppings, actually, let's go back here. Okay, when I start with the lettuce, right, when I'm putting it on, either the lettuce is going to be, you can have one piece now, or two pieces, or you could skip it, you can have 0, okay? So that means there's actually now 3 ways to put the lettuce on the burger instead of just 2, right? Before it was just on or off, and now it is 1, 2, or nothing. Okay, and I can do the same thing for tomato. Okay, and it would be like 1 or 2 or nothing. Okay, so there's 3 options for tomato. So now all of a sudden I have 9 instead of 4, right? I have 3 squared instead of 2 squared. Okay, so if you have the option for repeating, okay, then we have to count this a little differently. We start thinking about, okay, how many options do I have for the number of those items going on, okay? And again, we'll do an example of this to illustrate in a moment. So here are the 2 kind of new concepts we have here. Okay? Well, the first one's not totally new. We talked about it when taking up the homework the other day. Okay, a set with n distinct elements has 2 to the n subsets. Okay, so again, that's the idea that if I have something with, say, 4 items in it, you know, lettuce, tomato, pickle, and onion, okay, the total number of subsets, or total number of burgers that were there, okay, is now going to be 2 to the power of 4. Okay? And that's all the possible ones. Size 0, size 1, size 2, size 3, size 4. Okay, the second one is this. Okay, the total number of selections which can be made from P items of one kind, Q items from another kind, R items from another, etc. Okay, is P plus 1, Q plus 1, R plus 1, dot, dot, dot. Okay, so multiplying those all together, and then at the end subtracting 1. Now, this is kind of a special case here. Okay, so what this minus 1 is referring to is that if we were talking about the burger again, that you have to put something on it. Okay, this is removing, or this removes the empty case, or say the null set. Okay, so if the question is asking, we'll do an example in a moment, right? You know, I've got all this stuff and I want to pick some of it, right? That's possible subsets. Then that's what that minus 1 does. It says, I'm guaranteeing I'm taking something. I no longer want to count that option. Okay. Okay, and example 1 is going to talk about just that. Okay. A treat bag of Halloween candy contains 6 rockets, 4 sour candies, and 2 mini Snickers. How many different handfuls of candy can be pulled from the bag? So the way we're going to run this through is using that formula I just had. Okay, the idea is, well, there's 6 rockets. Okay, so that means when I reach into the bag, I could pick up 1 rocket, 2 rocket, 3, 4, 5, 6, or I can also pick up 0. Okay, so there's 6 rockets there, plus I'm going to add 1 because there's an option of selecting no rockets. Okay, same with the sour candies. There's 4 of those, so I can pick anywhere from 0 to 4 of those candies in my handful. So we do add 1. Okay, there's 2 mini Snickers. Okay, and I could have 0, 1, or 2 of those. Okay, and because I'm saying handfuls, that implies I'm definitely taking something out of the bag. So I subtract 1. Okay, and again, the reason I subtract 1 is because in here I've counted the case where I got none, right? That I reached into the bag and completely missed and didn't pick up any candy. Okay, and I don't know, most people don't miss. So we're going to ignore that case. So not enough, which is just 7 times 5 times 3 take away 1. Okay, so that's 104 different possible options. Okay. And again, the reason I'm doing this instead of doing choosing is because it's some objects, well, 2 reasons. Some objects are alike. Okay, I can't tell them apart. And 2, because I didn't know how many I was picking. Okay. Okay, and for our last example, we're just going to talk about some more general problem solving here. Okay, so like with permutations, there are situations where you're going to have to take cases, okay, or deal with restriction of some kind, or use indirect reasoning. And so we've talked about those things before. So we're just going to show you an example of where that can happen. So that's our example 2 this afternoon. Okay, in the card game 31, you're dealt 3 cards. Okay, how many 31 hands contain at least 1 face card? So how many different ways can you get a hand that has at least 1 face card in it? Okay, so first, just some number stuff. If you're not too familiar with cards, right? Standard deck has 52 cards, and 12 of those cards are face cards. Okay, so one temptation here would be to say, well, at least 1, so I'm just going to do some scribbling on the side here. Don't copy this part down. Okay, well, there's 12 face cards, and I need 1. Okay, and after I have that face card, I don't really care what else I get, because now I have at least 1 face card, so I'll just do 51, choose 2, right? From the 12 face cards, I pick my 1 face card, and from the remaining 51, I pick 2. Okay, and unfortunately, this is not going to give us the correct answer. Okay, and the reason it's not going to work is because it double counts some situations. So for example, my 12 choose 1, maybe I picked here the King of Clubs, okay, as my face card, and over here, in the course of picking my 2 other cards, I got the Jack of Diamonds. Okay, but maybe my 12 choose 1 was the Jack of Diamonds, and the King of Clubs was selected over here. Okay, so that's been counted twice, right? King here, Jack there, or Jack here, King there. It's been counted 2 times. Okay, and this isn't permutations, right? The order doesn't matter, so this is a problem. Okay, I've overcounted what I need to do. Okay, so that's not what we're going to do. Okay, so the first method I'm going to show is the indirect method. Okay, because it's a little bit faster. Okay, so because that's kind of annoying, what just happened there, well, it's pretty easy to count getting no face cards, so we'll do that. Okay, so we start with what are all the possible what's the total number of 3-card hands? So there's 52 cards, pick any 3, so there's 22,100 ways I can pick those cards. Okay, now I count the hands that I don't want. So I don't want a hand with no face cards. Okay, so with no face cards, well, from the 12 available face cards, I don't get any. Okay, from the remaining 40 cards, I have to pick my 3. So that leaves me with 9,880. And if I subtract the difference, if I take the difference, okay, that's 12,220 possible ways that can happen. Okay, so just to verify it, I'm going to go through and count it the other way, so with direct reasoning. Okay, so the shortcut I wanted to do there at the top didn't work. Okay, so that means I have to take cases and do it step by step. Okay, so when I say at least 1 face card, I have to separately count the cases for exactly 1 face card, exactly 2 face cards, and exactly 3. Okay, so for 1 face card, there's 12 of those available. I pick 1. There's 40 other cards, choose 2, and there's my total. Okay, and now I'm going to do the same thing for 2. Okay, it's 12 choose 2, 40 choose 1. And finally, for all face cards, it's 12 choose 3, and 42, 0. And when I add those all up, hey, look, I get 12,220, just like I did before. Okay? So either method works, just whatever one is your preference. Okay, but usually, okay, in problem solving with combinations or permutations, if it says at least, you have to break it down in the cases. Okay, there usually isn't a shortcut where you can just do it all in one calculation. Okay, you just have to break it up. All right. So your practice work. Okay, there's just 8 questions there. Okay, but they're kind of varied and go all over the place. So you're gonna have to think a little bit as you try to set up your answer. Okay, so enjoy the rest of that, and I will see you tomorrow.